Hello everybody, welcome back to my YouTube channel. I hope you all are doing great and staying safe and amazing. And today we're going to be talking about where the function is basically undefined, where x at equals to r is not differentiable. Essentially what I'm talking about is all or almost all the scenarios among the scope of my book, among the scope of my curriculum, what's defined and what's not. By the way, this that I basically brought informations from myself, from a teacher named Mr. Ibrahim. Let me just credit goes to him as well. There's some credit goes to him as well. But mainly, I wanted to mention Mama Talayat because that's where I really got most of the graphs from. I did change it a bit because I didn't want to steal all of his work, but I must say a good chunk of it is from him, so credit goes to him as well. Talayat Abdul Wahid. Okay, so that's his name. Check him out. He's amazing. Okay, so when x equals to r, there is a discontinuity. All right, what I'm trying to talk about is that, look, we've essentially studied that one of the key characteristics of differentiability is that there is continuity, okay? We have to have a continuous function. But I'm not going to say that all continuous functions are differentiable, because that's not the case, really. Really, that's not the case. Because, if you look at it, we'll look at some examples. I think that's something you probably should have studied yourself, but yeah. Look, at r equals to 0, okay? Oh my God. Okay, at r equals to 0, it's not defined in the domain. Look, limit does exist. Left and right limit, they approach the same value, which is r equals to x, r equals to 0. Now, we don't have a problem with the limit, but we do have a problem with, let's say, f of r not being in the domain, which is f of 0 not being in the domain. As you can see, there's like a hole, so it's not defined. And look at this, we have a vertical asymptote. The limits approach different values. There's on the left side of -1, we're approaching negative infinity. On the right side, we're approaching positive infinity. So obviously, there's a vertical asymptote. It's still not in the domain. It's still the limit does not exist. Actually, even let's say if at a point like this we had, even if the function was defined at -1, still not, because the limit does not exist and the function is not continuous. All right, okay. If we look at the third example, you can see that the limit does not exist, and not only that, it's not continuous because the limit does not exist, and f of -1 does not look equal to the limit at r equals to -1. What am I doing? Sorry. What happened? Oh my goodness, what happened? Okay, I'll just go with color. Okay. So there's that, okay, there was that. And if we can look at this one, yes, indeed, at r equals to -1, the limit does exist, but it's not continuous because left and right, the limit does not equal to f of -1. So there's that. Pretty easy. The discontinuity is not so fun. It's pretty easy. Now this is where the fun starts. Hold on, sorry, my bad. All right, so there is a corner at x equals to r. Now, in Kurdish, they say goshe haya. Essentially what that means is there's angle, all right? And translated to English, it should have been, I don't know what the translation to English should have been, but the teacher said corner, so I just went with corner. And actually, I've searched it up. People refer, mathematicians, they refer to it as corner, so let's go with corner. All right, so there's essentially the vibe that I'm getting from this is that absolute values have corners. They're not defined because they're absolute values, right? And they also dramatically change if you take the different the derivative for it. So they dramatically change. These are some examples. Easy. Now these two are the fun part, the ones that I like. All right. Okay, let's talk about when there's a vertical tangent at x equals to r. Now, there was a little bit of controversy about this topic because I don't know, this is the first time in my whole life, It's my second year, but this is the first I'm hearing that, at essentially what my teachers had said, they were like cusp and vertical tangent, they're the same thing, and at both of them we have a vertical tangent and there's a cusp, and literally I just went with the idea like nukitir, okay, like this steep point, and I was like, all right, it took some people to actually convince me that like, look, what you have been taught was like, I don't want to say this, but it was wrong. I was like, thank you, I'll fix it right away. So I did fix it, thanks to everyone that helped me. So when there is a vertical tangent at x equals to r, let's talk about it. Look, there is a vertical tangent, as if you can see, the teacher has drawn it, okay? And I should have drawn it right over here as well. If I can, oh, that's too big. Let me try this one. Yep, that's better. So there's a vertical tangent at that place, at that point. Yeah. So, that's the vertical tangent. And look at this. That's also vertical see? Vertical tangent. All right. So the note goes to say this is the main part. This is the most important part because, look, sometimes they're not going to give you graph, and they're just going to give you something like this, and they're going to tell you, does it have vertical asymptote or not? And this is what not asymptote, vertical tangent, sorry. So this is what you're going to do. Look, if you're going to look at, the power that's over your parenthesis, and look, in this scenario, I have 3 over 4, right? Now, 3 over 4, it's like an odd over an even number. So 3 is odd and 4 is even, right? And what's going to happen over here is that when you take the derivative for it, okay, the left and the right, they approach the same direction. Actually, no, sorry. I meant to say, look, my bad. 3 over 4, look, when you take the derivative for it, let's just take the derivative for it. Okay, so x, my bad, I said something wrong. Let's fix it now. Okay, so we take the derivative for 3 over 4. There's x minus 4. So essentially what I'm going to do, minus 4 over 4. So there's 1 over 4. Right. See, look, you see, we don't have look, it's essentially like one of the examples like here. You see that on the left side, like it's not defined, or like on this right side, it's not defined. You're on the left side, it's not defined. So be careful of those. I've noticed that this is, pattern that I've noticed, and it's easy to notice, is that, look, when you have an odd over even, and we take the derivative for it, okay, one of the sides don't exist because it's not in the domain, okay? Be careful of that. That's something important. And let's do, so just memorize it. What I'm just trying to tell you is like, okay, look. Yeah, just memorize it, okay? All right, so what you got to do is just memorize it, that when the power is raised to an even number, odd number, okay, over an even number, that's going to be, there's going to be vertical tangents, so exists. All right, so for the second example that I do have is, hold on, my bad. Okay, if you look at it, 5 is an odd number, and so is 7. So when in the power we have odd over odd, there's vertical tangent. Now, look, that's the cool part. That's something that kind of differentiates it from everything else, is that when you take the derivative for it, let's say we have 5 over 7, x minus 1, so that's going to be negative 2 over 7. Look, when you, let me just write this down one sec. All right, look, when you draw the graph for this, or like on a graph calculator or whatever, because it's an even number, whether you plug a negative number or a positive number, whatever, from the left side, right side, you're going to have the same direction. That's the fun part. Look, I wrote something. I said the function's derivative, left or right, approach the same direction. I'll give you an example. Our same example, but I'll give you guys the graph. Look at that. Now they approach the same direction, which is to positive infinity. This is the example that I worked with. You can go grab another example, but it's all going to be the same. Don't you worry. So what I'm trying to say is that, look, this is very important. If we have an odd number over an even number, okay, if we have an odd number over an even number, there is going to be one side that's not going to be in the domain, but figure out that on your own. But for this one, particularly, which is an odd over an odd, they approach the same direction. All right, they approach the same direction because look at this one. The right side does not exist, so I can't say the left and right approach the same direction. And the same thing for here. The left does not exist. What am I going to say? Say they exist, they approach the same direction? Absolutely not. So when we say that they approach the same direction, the derivative left and right approach the same direction, we're really just referring to odd over odd. So there's that. Fun, very fun. Now look at this one. When there's a cusp at x equals to r, notice that there's like a cusp. That's a cusp, and so the properties about a cusp, they're actually very noticeable in a graph. You can see it, not so hard. By the way, these are from the graph of f of x. Okay, not the derivative, just f of x. Look. It says, the example that I have, it's x minus 1 raised to the power of 2 over 3. Now, if you notice, we have an even number over an odd number, okay? There was an even number over an odd number over an even number, but now we swap it, it's an even number over an odd number. The function is not differentiable because the derivatives, the left and right, they approach different directions. One approaches, let's say, positive infinity, and the other approaches negative infinity. Let me just give you an example. The same example we're working with, hold on a sec, hold on. Okay, let's go. All right, so we have x minus 1, 2 over 3, take the derivative forward, so that's 2 over 3, x minus 1, I really like this shade of yellow. It's really cool. All right, so let me just. All right, look at that, right? So when we put this on a graph, let me just show you the graph, right? Should show you everything with proof. All right, look at that, ladies and gents. What approaches from the right side approaches positive infinity, from the left side approaches negative infinity, and they dramatically change as they approach 1. So indeed there is a cusp. Well, the f of x must have been a cusp, and we are having different directions when it comes to the derivative. So it doesn't exist, but they like to give you examples, and they like to fool you around, but mainly the examples that they give, it's not graph, because the graph is easy to tell, all right? And they can give you graph. I'm not saying that they're not going to give you graph, but they can give you graph, but it's really much more fun and a bit harder for students if they go and bring, as values, and they just tell you, for example, okay, x minus 1 raised to the power of 2 over 3 at x equals to negative 1. Is it differentiable? And you're going to say no. It's not differentiable because we got a cusp, and the rule says even over odd, we have a cusp, so there's no, the function is not differentiable at that point. It might actually low-key ask you, the left and right, what do they approach? That's also a very reasonable question, but don't fear it, it's pretty easy. You just plug in some numbers on each side, and you're going to actually realize that, at that point it approaches negative infinity or positive infinity. And it might ask you an example, and the parenthesis is raised to the power of, let's say, by the way, all these powers, I forgot to say this, all these powers must be less than 1, all right? So 3 over 4, less than 1. 5 over 7, less than 1. 2 over 3, less than 1. If it were the other way around, if it was a number that was greater than 1, I'm not going to be dealing with numbers like that, right? So let's say x minus 1, approaches 3 over 2 at x equals to -1, the derivative does not exist at that point. Do you guys know why? Because -1 is not in the domain. But if I was just going to give you 1, let's say x equals to 1, you're not going to be saying, oh, we got a cusp where we got a vertical tangent. None of that. Nope, none of that. Okay, don't make such mistake. All right. So what you got to do is, first of all, tattoo this thing onto your brain. Like, I literally asked ChatGPT the other day, and it was like, look, girlie, you gotta tattoo this thing on your head, like maybe in your brain, whatever works for you, but you gotta know. The first thing you're gonna check is domain, because literally, before making this video, I was seeing, like, I saw a video, a post, and it was saying at x equals to -1, and it literally gave, like, the power was 3 over 2. And it said which of the following is not differentiable at that point. And we had to say that it was actually not differentiable at that point for 3 over 2. Why? Because it was not in the domain. Not because there was a cusp, or not because there was a vertical tangent, but just because of that. Also, I don't want to make this video too long, so there's everything you gotta know. The recap is just memorize everything that I just showed you, especially these like even or over odd, or like odd over even, odd over odd. Pretty easy, by the way, but you just gotta learn that. And yeah, enjoy this video. I hope you enjoyed this video. Bye-bye for now, and I hope you guys benefited from it. Bye-bye.